So as I mentioned, we mentioned so far is this, right? Machine learning in some way is a data analysis science, right? Data science. And we try to learn to improve the performance model direct from the data. So because of this reason, data is extremely important for machine learning. And so before you build any models here, it's always very good to check out the data sets here and get a feeling in terms of what the data look like. And for that purpose here, there are some of the very basic things we should be able to aware, right? For instance, and we should be very clear about what types of data do we have. Is the data is binary values, right? And for instance, if you build a spam email detectors here, and in that case, you would, is the email is a spam or not, right? Sometimes whether it describe a person, a patient, is patient a male or female? Is gender? Those are the binary values of that. But sometimes their data are more like categorical, right? So they're not necessarily binary, but it belongs to the discrete set of values here. For instance, and which states you live in the United States, right? So there are, and what labels, and what maybe different classes of labels of that. And whether their values is integer values or not. So for instance, for ratings, right, you typically have integer values, 1 to 5 stars, and you might have the discretized continuous values. That's very common as well. For instance, and in describing the age distribution associated with disease, we might have an age bracket. We say, before 18 to 30, 30 to 50, right? And then you put those patients in different brackets based on those age distributions of that. So as a result of that, and then in that case, you have a categorical values of that. Or maybe the value is real values of that. For instance, if you look at the images, and the images are described by a two-dimensional arrays of pixel values. Initially, it could be integer values, could be continuous numbers of that, or prices of homes, and etc. So it's always good, kind of in the very beginning, try to get a sense of what types of data do we have, and how do we handle each type of data sets here. Sometimes it's not so obvious how to handle them. For instance, and how to handle categorical values, right? You have 1, 2, 3, 4, 5. And how to use that, how to handle this in our machine learning problem. And then we're going to talk about that, how to handle them. It's not so obvious to do that. And secondly, and most of the time in the many real applications, you are provided with Excel files that contains all the data sets. And it's very common that in many cases, your entries are missing. There's no data associated with some of the entries. Or in the Python, you might have NA values, right? So in that case, how do we handle those missing values within your data sets? And one way is might be just throw those data sets away. And we only handle those data with complete values of that. Of course, you'll lose information by doing that. And maybe a better way is try to kind of impute those missing values from existing data sets to do that. And the question, how do we do this? So that's also very important to to take a look at data sets here to see whether there are missing values associated with data sets here. And then the next one would be in terms of distributions of the data sets here. What are the clouds? What are the shape of the data sets? Are there any outliers associated with the data sets here? And if there are outliers here, should we remove these outliers? How do we handle them? And those things here, you can also easily check through some of the data visualization tools. You don't need any sophisticated methodology, but doing a very simple data exploration will help you get familiar with the data set and get a sense of what data set look like. So, so in terms of the scientific software for dealing with data sets here, doing machine learning, as I mentioned here, in this class, we primarily use Python here. And then within the Python, very frequently, this modules here called a NumPy module. So in this NumPy modules here, essentially you can think about it is if you're familiar with MATLAB, essentially you can think about it as represent a data type associated with arrays. And if you have arrays, how to represent them efficiently, how to do computation efficiently. And that was all done within this NumPy modules. And I highly encourage everyone to get very familiar with NumPy. And this is a library that you can use to plot your data and represent data in graphs, in images, in three-dimensional plots, and in bar graphs, etc. If the routines implemented in MATLAB now are implemented in SciPy. So for instance, you want to calculate, eigenvalue decomposition of the matrix, do a principal component analysis, you will know some of the routines of that. So the Python modules, Python is very convenient. I highly encourage you at least look at these three modules, or if you don't have time, at least look at NumPy and Matplotlib modules here, and I'll get you familiar with them. So they are, of course, they are. If you are later on, we're going to say something about deep learning. In that case, the platform for implement deep learning models will be primarily based on either TensorFlow or PyTorch kind of platform. These are two dominant models, platforms for building deep learning models. And we might have time to say something about them. I think if we teach them, we will primarily focus on the PyTorch framework for building deep learning models. And that will be probably in the later part of the class if we have time to get over to the deep learning models. I think we have. Yeah. So of course, there are many other scientific softwares here, MATLAB, R, and C, and so on. And they're still very useful for many different purposes. For instance, R is extremely useful for statistics, for many applications in statistics. And for instance, you want to build a hypothesis testing, and then still R will be very convenient to do that. And the C++, of course, for performance issues. Of course, the Python here, in many cases, if you, and most of the time, it's not as efficient as C++, right? So if you want to make your applications extremely efficient, in that case, C++ will be very useful. Of course, and for our class here, probably we would not be able to use that because, and our primary focus is try to learn the basic concepts of machine learning. So Python will be perfect for that purpose. All right.